one more time with the feeling. Let's work out with this old quiz I gave. It looks pretty simple as I look across it today over the Isosceles triangle theorem and the triangle sum theorem. Let's see how these things go. I think you ought to feel more confident after this. Probably already feeling pretty confident. Make these notes in the figure out right. The measure of angle A is 40. M is the midpoint of AB, so I figure that this segment's as big as that one. And CM's the same as MB, so there we have these three segments congruent. I'm going to figure out all these angles right off the bat. I mean, I got a couple of isosceles triangles. This is an isosceles triangle. So who are the base angles, you'd be thinking? Well, I think that A and C would be the base angles of that one. So I know the measure of angle A, measure angle 1 already. It would have been 40 degrees. Put into my figure, I think it might be helpful when I start looking around. And then I got to find out about the measure of angle 2. Now I got a couple of angles, 40 and 40, that adds up to 80. That tells me angle 3 is going to be 80, but it tells me angle 2 would be 180 minus that 80, therefore angle 2 is going to be 100. And clearly if this angle is 100, that angle would have to have been 80. I like you to remember that the exterior angles equal the sum of the remote interiors. Those guys right there, and add up this one. But now, since I know that angle 3 is 80, I'm going to figure about this for angle 4. This is an isosceles triangle. These are the legs. These must be the base angles. They must be congruent, this one and that one. And 80 degrees went there. Therefore, these two angles would have 100 to share. Must be 50 here and 50 there. We call an angle 4 50 degrees. Hope you agree with me. Here it describes an isosceles triangle PQR with base PQ. Tells me about some of the angles. I gotta make a sketch. I think I'd be better equipped if I did. Isosceles triangle PQR with base PQ. So these must be the legs. And here we have the base angles, which ought to be congruent. Angle P, yeah, that's 8x minus 5. Angle R, the vertex angle, that's 2x plus 10. I got to find a way to write an equation. That's all the time looking for equations and find x and measures of these angles. And probably what you're thinking, I hope what you're thinking is that angle Q would be just like angle P, also 8x minus 5. Base angles of an isosceles triangle got to be congruent. Therefore, we can say 2 of those 8x minus 5s plus that angle at the vertex 2x plus 10 has to add up to 180 degrees. Distribute that 2 through those parentheses. We got 16x minus 10 plus 2x plus 10. Oh, this is going to work out kind of pretty, huh? Equals 180. I got this 16x and this 2x. That's 20. Excuse me. That's 18x. A negative 10 and a positive 10 adding out to 0. So I got 18x equals 180. I bet you feel like I feel that x must be 10, huh? And I'm supposed to find the measures of those angles. So I think we can do that pretty quick. How about the measure angle P? 8 times 10 is 80 minus 5 be 75 degrees there. I figure angle Q would be the same. Now if these two add up to 150, this would better be 30. And we'll check on that now. What about the measure of angle R? Bearing in mind that x is equal to 10, that'd be 2 times 10. There's 20 plus 10 be 30. And I'm happy. These are good looking angles for an isosceles triangle. Let's play some more. Angle A, 7x plus 4. Angle B, 3x plus 46. And I know something about this exterior angle. This is a friendly question in 130 degrees right there. And I hope what you're realizing, you know what you could do? You could call this angle 50 and add them all three up to 180. That would work just fine. Or you can say that this angle equals those two added up, and that would work beautifully as well. That's where I'm going to go. I'm going to say 130 is equal to 7x plus 4 plus 3x plus 46. gather like terms on the right hand side, get lots of practice solving equations. I got 7x and 3x, there's 10x. Got this positive 4 and this positive 46, there's 50, huh? Subtract 50 from both sides. That would leave me with 80 is equal to 10x. Divide both sides by 10. And you are, as I am, convinced that x is equal to 8. Let's go find out about the measure of each of those angles. Measure angle A. If x is truly 8, 7 times 8, 56, plus 4 be 60. Measure angle B. 3 times 8 is 24, plus 46. That'd be 70, wouldn't it? Hey, that's good, because they got 60 and that 70 add up to that 130, don't they? That worked out as it should. Here's a friendly old question that you know a lot about. Angle P and angle Q and angle R. Angle P and Q and R. They give these measures for them. I know what to do with this, and I bet you do too. We'll add them up to 180, because the angles of every triangle must add up to 180. Angle P plus angle Q, 10x minus 10. Plus angle R, 5x minus 5, adds up to 180. Jump in and start gathering like terms. I got 10x here and 10x there and 5x there. Looks like 25x to me. A positive 20 and a negative 15. Positive 20 and a negative 15, that'd be a positive 5 equals 180. We can clean this up. We'll subtract 5 from both sides. I got 25x equals 175. Divide both sides by 25, and I'm convinced that x is equal to 7. Let's go find out about the measure of each angle. Measure angle P. If x is truly 7, that'd be 10 times 7. 70 plus 20 would be a 90-degree angle. Oh, this is a right triangle. That's a right angle at P. Angle Q, what about the measure of angle Q? If in fact x is equal to 7, then 10 times 7 is 70 minus 10 be 60 degrees. Oh, this must be a 30, 60, 90 triangle. What about the measure of angle R? R is 5x minus 5, and x is equal to 7, so 5 times 7 is 35 minus 5. Yep, that's a 30, isn't it? So, we have the beloved 30, 60, 90 triangle, which will be part and parcel of what we do next semester. We'll know all about the beloved 30, 60, 90 triangle. But let's do one more of these, and you'll walk out the door today feeling pretty comfortable. Interior angles of a polygon are in a ratio of 2 to 3 to 5. Write an equation that fits. Measure the interior and exterior angles for our triangle. Make a sketch and find those exteriors. So, angles of a triangle are in a ratio of 2 to 3 to 5. Anytime anything's in a ratio of 2 to 3 to 5, I can call them 2x, 3x, and 5x. For any value of x, these would always be in the ratio of 2 to 3 to 5. And if they're the angles of a triangle, let's add them up to 180. So, gathering like terms on the left-hand side, I see 10x there, don't you? 10x equals 180. So I'm convinced as I divide both sides by 10 that x is equal to 18. So one of my angles had to be 2 times 18. There's 36 degrees. Another one should have been 3 times 18. That'd be 54 degrees. And then there's 5 times 18. That's 90 degrees. I'll make a quick sketch. Not trying to burn too much of your time, but I'll try to show that sketch and find out about those exterior angles. I'll extend some sides so we can get that quickly done. And extend a side here. Let's say this was the 36, and this is the 54, and this is the 90. If these are interior angles, let's talk about the exterior angles. That ought to be easy enough to do. This exterior angle, the supplement of 36, equals 90 plus 54, 144 there. This exterior angle, the supplement of 54, must be 90 and 36, 126 degrees there. And the last exterior angle is 90. Be nice to list them in order from least to greatest, but this is okay too. I got the measures of those exterior angles, and I bet that makes you feel pretty comfortable with these ideas. Good deal. Get this quiz done this week, or this test done this week. Appreciate that you would. Thank you, boss.